So for dividing polynomials, we just need to remember we have some different notations. First of all, we have a trinomial divided by a binomial, which is the same as a rational expression. So it's the same exact thing, which is the same as multiplying using the -1 for an exponent. The -1 exponent puts it in the denominator, and you wind up with exactly this thing here. No matter what format you see, I recommend, if you look at this one or you look at this one, I recommend making it this before you move on. And that's how we're going to look at these sorts of expressions all year long. So this one would be x squared plus 7x minus 30, what? X minus 3. What's the operation going on there? Yeah, it's division. So we're going to deal with long division or synthetic division in this supposed section. Before I do long division, though, let's take a look at that bottom note. If you have missing terms, like if you start with an x to the 4th power, and it goes x to the 4th straight to x squared, you have to include a 0x to the 3rd. That middle term in between those two terms has to be included in order for your division to work. And that is true no matter what division you're doing, long division or synthetic division. So keep that in mind. All right, so let's do this one as long division. I'm going to take x minus 3 outside, divided by or into, whichever one it is, x squared plus 7x minus 30. I didn't have any missing terms, so I don't need to include any zeros there. So now what I do is I ask myself, what times x gives me this front term, x squared? The answer is x. And I'm going to write that answer directly above my x term underneath my division thing. And then what I do is I take x and I multiply it times my binomial sitting over here. So x times x is x squared. X times -3 is -3x. And then just like with long division, I draw my line. And what do we do in long division now? In 4th grade when you learned long division, what did you do? You subtract. Well, here, instead of just putting a minus sign here and then forgetting that you're subtracting everything, we're going to change all the signs and add. Yeah. So I'm going to make this negative and this positive, and then I'm going to add. And my x squared plus -x squared disappears, which is good. I need that to happen. And then 7x plus 3x is 10x. Then I bring down my minus 30. And then I just repeat the process until I'm at the end. What times x gives me 10x? 10, so I'm going to put plus 10 because it was a positive 10, and then multiply through. 10 times x is 10x. 10 times -3 is -30. I draw my line. I subtract by adding the opposite, so I change all my signs and add. And I get 0. So there is no remainder. We're done. This is the answer. Or I could use synthetic division. Do you want to see that same problem with synthetic division, or do you want to see the other problem with synthetic division? Doesn't matter. What? The other one? Okay. So we'll go on to this one. Synthetic division is set up a little bit differently. All I need to do here is draw a box, a line. What goes inside the box? So positive 1 or negative 1? Positive 1. Actually, what goes in the box is if you were to take this denominator and set it equal to 0, and then solve for x, you would get the root. The root is what goes in the box, so that's why the sign changes there. All right, and then outside the box, across the top, I need to write all my coefficients. So it's going to be 1, -13, positive 12. I don't need to include any zeros because all my terms are present. What do I do now? The 1 comes down. And then what do? I add. Negative 13 plus 1 is negative 12. And then I just repeat that process until I get all the way to the end. Negative 12 times 1 is negative 12. 12 plus negative 12 is 0. So I have a remainder of 0. If this was not 0 right here, this would be my remainder. And we'll talk about how to deal with remainders in a second. Okay. So as the heading on this page indicates, we're going to have a remainder on this one. I'm giving you the different notation here. This looks like it's a multiplication problem, but actually it's a division problem because of this negative 1 right here. So I'm going to rewrite it. We'll have a squared, let me write the a first, plus 7a minus 11 divided by 3 minus a. Anything wrong with the way this is written? I don't like that either too much. So there's a couple of options we can do. We can factor a negative 1 out of here and put that negative 1 up there, which would reverse these two, or we can reverse these two, or something. But we're going to have to do something. And what method do you want to use? I don't know what you guys prefer, long division or synthetic division. Synthetic? Tell you what, let's do both. See what we do. So I need to reverse these two. In other words, I'm going to have a squared plus 7a minus 11 divided by negative a plus 3. Now I'll set up my long division. Negative a plus 3 divided into a squared plus 7a minus 11. So now ask yourself, what times negative a gives me positive a squared? And the answer is, what? Negative a, yeah. So negative a times negative a is positive a squared. Negative a times 3 is negative 3a. Subtract by adding the opposite, so I change all my signs. That's gone, and I have 10a. Bring down the minus 11. What times negative a gives me positive 10a? Negative 10. So that becomes positive 10a. Negative 10 times positive 3 is negative 30. Draw my line, change all the signs, and add. That's gone, but I'm left with whatever that is, positive 19. So I have a remainder of 19 here. What do I do with that? In 4th grade, what would you do with your remainder? R19. Yeah, you'd write the remainder right here. You'd have negative a minus 10, R19. But we're not going to do that. Instead, what we're going to do is we're going to say we have to stop here. We can't divide this 19 by negative a plus 3. Well, this is a positive 19, so plus 19, and I can't divide that 19 by negative a plus 3. So I'm just adding the remainder on, and it's being divided by what I divided by. That's all it is. It's like a fraction. I can't divide 3 divided by 4, so I just leave it 3 divided by 4. So let's set up synthetic division now and see if we can get the same answer. Interesting question. What's going to go in the box? It's positive 3. The root of the denominator is positive 3. The thing that makes the denominator 0. So I set up my box 3. My coefficients across the top are 1, 7, and negative 11. Divided by, well, that's not divided by, whatever, that line. 1. 1 times 3 is 3. 7 times 3, 7 plus 3. What am I doing? Plus 30, 19. I get the same answer. Here's my remainder. When I'm done, I didn't do this on the last synthetic division problem. What do I have to do? Yep, put the variables back in. So this is a 1, a to the first power. You decay the exponent by 1 when you do that. So we have x plus 10 plus, a plus 10 plus, I need to start paying attention, 19 over negative a plus 3. There's your answer. Is this the same answer? The negatives in there screwed me up. So, is this the same answer? Doesn't look the same, but is it the same? Is negative a plus 1 the same as a minus 1? No? So which one's right then? We're going to do a lot of factoring in this class, and you need to remember how things factor, those patterns of factoring. And the second degree ones are the ones that pop up the most. We do have some third degree ones pop up too. This is the difference of squares. I have a perfect square here minus another perfect square here. If you have that situation, it factors automatically into the pattern a plus b times a minus b. This one would be called a perfect square trinomial. It will always look like this. It will be a positive a squared, a positive b squared, and then either a plus or a minus in the middle. And to find that middle term, I take the square root of that, the square root of that, and then I double it. And if I get the middle term, then it is a perfect square trinomial. And if you have a perfect square trinomial, it automatically factors into the quantity a, whatever this sign is, b squared. The third one here is the one that everybody loves to screw up. A squared plus b squared does not factor. It never can, it never will, unless you want to go into complex roots. It does not factor. So, down below, rational expression is one that has a ratio of two polynomial expressions. It's a polynomial divided by a polynomial. Earlier we were looking at rational expressions. We just weren't calling them that. We were calling them long division problems. Well, that's all rational expressions are. So, we need to learn how to, your favorite word, cancel common factors. But what we're really going to be doing is forming fancy ones and letting them turn into one so that they disappear. So if you remember back in whenever you learned how to, what am I doing here? Simplifying, what's the R word that we use there? No. Reduce, yeah. Think back to Algebra 1. You're reducing fractions here. 8/12 reduces down to 2/3. It doesn't just reduce down. Nothing ever just does anything. There has to be some math behind it. And usually when you say, oh, it just does something, there's a fancy one going on. And here it is right here. What you do is you figure out the greatest common factor that goes into 8 and 12. And then you break this number in the numerator into that factor times the other factor that gives you 8. And likewise for the denominator. So for 8 and 12, the greatest common factor is 4. Well, what times 4 gives me 8? 2. So I split this into 2 times 4. And then the denominator, what times 4 gives me 12? 3. So I write this as 3 times 4. And that gives me 4 divided by 4, which is 1. So I'm left with 2 divided by 3 times 1, or just 2/3. That's the math behind reducing fractions. So now, if you want to think of this as 8/12, all I have here is a fraction. So what I need to do is find the greatest common factor of the top and the bottom. And in order to find the factor of the top and the bottom that's going to work, I need to do what to the top and bottom? I need to factor them. That's right. So I need to remember how to factor. How do I factor the trinomial that looks like that? Two groups of parentheses. Now what? Yeah? X minus something and X what? Minus. Minus times minus gives you plus. That's the only way this can happen. Alright, I need two negative numbers that multiply to give me positive 3 and add to give me negative 4. You don't have a whole lot of choice there. Yep. So, there we go. The top's factored. Now the bottom, same idea. It's a trinomial, so I can break this into two groups. We'll put x and x in there again. My signs have to be both negative. Two numbers that multiply to give me 5 and add to give me negative 6. Negative 5 and negative 1. Okay, now the thing's factored. Do I have any fancy ones that I can get rid of? Yeah, the x minus 1 is common to the bottom and top. So I'll go ahead and use your canceling notation where I'm drawing a line through them. They're gone. They turn into a 1. And I'm just left with x minus 3 divided by x minus 5. Now that's my answer, almost. This is something that you should know how to do already, right? You guys have done this before. Okay, but this isn't my answer. I need to also have what x can never be. X can never be what? X can never be 5, because if I have 5 minus 5, I get division by 0, and that can't happen. So x cannot be 5. Is that it? What? That's it? No. Okay, if it's 0, I don't have division by 0 here, so I'm good. If it's 3, I don't have division by 0 here, so I'm good. No. That's just 5. I need to go all the way back to the beginning, before I canceled, before I formed my fancy ones. This is what we're looking at. It does reduce down to this, but when we're just looking at this, if you were to graph it on a calculator, you would actually have a hole at what number on your graph? 1. We'll talk about why it's a hole later on. But you would have a discontinuity right here, because you would be dividing by 0 if you had 1 minus 1, because that would turn into 0 times whatever this is. So we have to also include 1. X can never be those two numbers, even though we got rid of that situation. The original problem had it in there, so we have to be careful about that. So for the top, does 5x factor? No. Does this factor? Yeah, so I'm going to turn this into 5x times some stuff. What is my stuff? X plus 1, x plus 3. Check it real quick. 1 times 3 is 3. 1 plus 3 is 4. So I got it right. Divided by, does the bottom x minus 6 factor? No. So I'm going to rewrite it, x minus 6. Does x squared minus 9 factor? Yes, that's one of our special cases. What does it turn into? X plus 3, x minus 3. That needs to be automatic when you see those. Okay, do I have any fancy ones I can get rid of? What? All right, x plus 3 is gone. Anything else? That's it. So my answer then, simplified, will be 5x times x plus 1 divided by x minus 6 times x minus 3, and that's it. Oh yeah, I got to include x. X can't be what? Can't be 6 for sure. Can't be 3 for sure. And also, I got rid of this x plus 3, so therefore, I'm going to turn that into a plus or minus 3. So there's your answer. This is your maybe second time seeing an answer that's written like this. That is perfectly acceptable. You do not have to FOIL it back out or use the distributive property. This is the answer. Okay, back to, this is something that we did cover in Algebra 1, or that we do cover in Algebra 1, but you first learn how to do it probably in 5th or 6th grade. You just don't see it with letters is all. What am I doing right here? So the top one is simply multiplying fractions together. You multiply across. Okay? The bottom one is, okay, the way we remember this is leave it, change it, flip it. What am I doing? I'm dividing fractions. Alright, so let's simplify this mess. And this is the sort of mess we'll see a lot this year. That's a big mess. What would be nice is if I didn't have to FOIL all that out. So, How many of you want to FOIL it out? Nobody. How many of you think that's what we're going to have to do? It's calculus, so you got to FOIL it all? No. What we've been doing all along is breaking it into factors, getting rid of fancy ones, and now what we're going to do is do that, and then we will multiply across and leave those factors. We're not going to FOIL. So we need to rewrite this guy. It's going to break into what?
Correct. He's not around.
1 is going to be and positive. What are my two numbers?
2 and 8.
Which one's which? Right. It's going to be negative 8 and positive 2. All right, go to the denominator. This also factors. Happens to be a special case, but you don't need to know that. It's a perfect square trinomial. X minus 8, x minus 8. Times, on the right-hand side, x minus 8, does that factor? No. I'm going to put it in parentheses just for fun. Does the bottom factor? Yeah, into what? X plus 3, x plus 2. Okay, now it's all nice and factored out. You guys would still be FOILing the top at this point, but we are one step away from being done. Do we have any fancy ones to get rid of? Yeah, we do. What? X minus 8 and x minus 8 right here. Any others? Another x minus 8. And when I get rid of that, what does it turn into? On top. Yeah, there's a 1 here now, not 0. Anything else? Right, the x plus 2's are also gone. And I'm left with 1 over x plus 3. And there's my answer. Very nice. Do I need to exclude anything? Oh, yeah, I probably should. What should I exclude? X is not equal to negative 3. What else? Can't be negative 2. Can't be positive 8. Anything else? Okay, that does it. That's the answer. So what's my first move here? Yeah. So leave it, change it, flip it, right? A plus b divided by 4 times 4 divided by a squared plus b squared. All right. The 4's are a yes. So those are gone. They turn into 1's. What else? That's it?
Can you get rid of the A's? Or? No, I didn't think so. Okay, that's what I like to do.
Right. But what? Do I need to pause? So as of right now, I have a plus b divided by a squared plus b squared. The question is, can I simplify that down any farther? In this case, since there's more than one variable in the denominator, you can't exclude any numbers unless you had a and b both being 0 at the same time. So are we done, or is there more? You think we're done? All right. Come on. What am I doing here? So yeah, to add fractions together, I need a common denominator. My common denominator here is going to be my least common multiple of the denominators. And the least common multiple of 6 and 9 is 18. So what will I have to do to this fraction to get 18? The fancy one will be 3 over 3. So I'm going to multiply times 3 over 3 over here. And on this one, I'll multiply by 2 over 2. The point is, when I figure out what the common denominator is going to be, I need to multiply this one times the factor that's going to give me that common denominator, and this one times the other factors that are going to give me the common denominator. And then I can add them together. So in algebra, we have to do the same thing. I give you this mess, and as of right now, we can't do anything with it. But if I factor the denominator, I'll have 3 over what? X plus? Oh, okay. Yeah, we got to have minus there. X minus, and you said 2 and 1? 2 and 1. Okay. Then we have plus 5 divided by, can I factor that? Probably yes. So I pull the 2 out. X squared minus 1. Right, so this whole thing turns into 2 times x plus 1 times x minus 1. Alright, now it's all factored down, and I can clearly see what my common denominator needs to be. It needs to be all of these. What happened there?
I forgot the X. I was going to mention it, but you were so on a roll.
Yeah, I'm pretty excited right now. So it needs to be all of these and all of these in the denominator. So in order to do that, I'm going to need a 2, so I'm going to put that 2 over here, but it needs to be 2 times 3 there. I'm going to need an x plus 1 because I don't have one over here, so I'll put that there. X plus 1 and x plus 1. And I have an x minus 1 here, and I already have that x minus 1 there, so that one's good. But now, let's see, I added those 2 on. I have an x minus 2 over here. I don't have an x minus 2 over here, so I need one. X minus 2, and then x minus 2. And again, that x minus 1 is already there. So check to make sure we have the same factors in the denominator. 2, x plus 1, x minus 1, x minus 2. 2, x plus 1, x minus 1, x minus 2. We do. Now we have common denominators, and we can actually add these together. So, I add them together. The denominator is going to be 2 times x plus 1 times x minus 1 times x minus 2. And then the numerator, we're going to have to distribute that out and simplify it down. This is your first case of, yes, I actually do have to FOIL out or distribute. So this would be 2 times 3, which is 6, times x plus 1, plus 5 times x minus 2. And now distribute in the numerator and then combine like terms. And I don't have any room, so I'm going to go up here. This is 6x plus 6 plus 5x minus 10. Combine like terms. 11x minus 4, all divided by my common denominator. 2 times x plus 1, x minus 1, x minus 2. There's your answer.